From the Atlantic to Africa, from America to Azerbaijan, we have conquered the last frontiers of our planet's land surface. Now there are just two frontiers left to explore, outer space and inner space. The hopes all of us have for a better future could very well depend on our ability to master this inner frontier. One of the missions of the United States Navy is to develop an ocean engineering and construction capability. The Naval Facilities Engineering Command and the U.S. Navy Seabees have completed 3 major underwater construction projects. The work was part of 2 programs, Tektite 1 and the Azores Fixed Acoustic Range. Tektite involved the installation and support of an undersea habitat. The experiment took place off the southeast coast of St. John in the Virgin Islands, where 4 aquanauts lived and worked continuously underwater for a record 60 days. The Navy cooperated with other government agencies in this project. These included the National Aeronautics and Space Administration and the U.S. Department of Interior. The habitat itself was built by the General Electric Company. The first operational task involved launching the 160-ton habitat. Since the cost of a floating crane was prohibitive, the Navy launched the habitat by the controlled sinking of the barge supporting the habitat. To prevent tilting of the barge as it submerged, pile guides and small winches were used. After launching, Navy Seabees towed the floating habitat to its emplacement site. There, they carefully winched it down to the bottom, then stabilized it on the ocean floor with 20 tons of pig iron ballast. Habitat support systems had been pre-assembled by the Seabees on a specialized platform known as an AMI pontoon. These systems consisted of drinking water, air, electric power, communications, and a monitoring and control van. The pontoon was hoisted from the water on pile legs to prevent ecology-disturbing noises from entering the water through the pontoon bottom. After all systems were checked out, the aquanauts moved into their new underwater home. The habitat itself consisted of 2 steel vessels divided into 4 compartments. Living quarters and the operations bridge were in one cylinder. Machinery and wet rooms were in the other. The aquanauts enjoyed many of the comforts of home, including radio and television. During the course of their 2-month underwater stay, the aquanauts, all of whom were graduate marine scientists, performed various geologic and oceanographic studies. Some of these involved the gathering of ocean specimens and the tagging of fish with electronic sounding devices to follow migratory patterns. The aquanauts, in turn, were studied by Navy and NASA psychologists and physiologists who monitored all parts of the experiment. After 8½ weeks underwater, the aquanauts and the habitat were safely recovered from the sea. Tektite was a success. The Navy's contribution to it proved that complex subsystems built off-site can be rapidly, safely, and economically installed on-site to support human life and exploration beneath the sea. The next project, called Azores Fixed Acoustic Range, or AFAR for short, occurred in 2 stages. The first took place at AUTEC, the Atlantic Undersea Test and Evaluation Center, located on Andros Island in the Bahamas. The Navy wanted to find out if a new underwater sound antenna array developed by the Naval Underwater Systems Center at New London would perform according to specifications prior to implanting it and 2 similar arrays on seamounts off the Azores Islands. A site for the array and the cable path was selected by the Pisces 3, a 2-man submersible. Construction began with Navy Seabees laying submarine cables from the shore to the installation site and buoying the ends off at the surface. This was done using an inexpensive cable winch mounted on a general-purpose construction support pontoon. The pontoon was propelled and positioned by 4 corner-mounted outboard units. The array was towed to the site and submarine cables were spliced into it. To launch the array in 1,400 feet of water, the Navy developed another version of the underwater elevator system initially used in the Tektite project. Pontoon stability was provided this time by large floats connected by cables to winches on the corners of the barge. CB divers operated these winches manually to lower the array barge as it was progressively flooded. At a depth of approximately 40 feet, the array was launched from the pontoon elevator and was prepared for lowering. Lowering was accomplished by means of the constant tension cable laying winch. Simultaneous payout of the lowering line and hauling in of another line to a single taut moor resulted in a gentle and precise installation. The array finally came to rest midway between 2 sea cliffs in 1,400 feet of water on the ocean floor. For the 11 days following implantation, engineers from the Naval Underwater Systems Center performed tests on the antenna. The system checked out perfectly. The next week, the Navy Seabees who had assembled and installed the array retrieved it and brought it ashore. The AFAR test proved that large, complex, but delicate equipment can be efficiently and inexpensively implanted in the deep ocean if proper planning and careful execution procedures are utilized. Also, the successful accomplishment of the first part of the AFAR test led to the second phase, which took place near Santa Maria Island in the Azores. This phase of AFAR was a NATO nation project involving 8 different countries. Each played a role in the placement of 3 underwater sound antenna arrays in a large horizontal triangular pattern on the ocean floor. Civilian engineers and Navy Seabees made up the American contingent. It totaled 80 people in all. In this project, the United States supplied the antenna arrays, installed the near-shore and onshore submarine cables, and installed the laboratory and power equipment. In the first part of the cable installation, Seabees had to blast smooth the steep sides of crevasses along the planned cable route. Special rigging was then installed to haul the cables from the cable ship to the shore for further connection to a laboratory. While the cable ship, the Salernum from Italy, was anchored a short distance away, bulldozers hauled the cable ashore with a connecting length of grapnel rope. Floats were applied to the cable to prevent contact with the sea floor while being hauled ashore. Split pipe for protecting the cable in the surf and surge zone of the onshore area was then applied over the cable. An innovation devised on-site cut the split pipe installation time by a factor of 15. The Navy moored an amphibious causeway section 600 feet off the beach. On this floating platform, Seabees placed sections of the heavy split piping over the cable. 75 feet of piping was installed before each section of cable was removed from the pontoon. The result was a more efficient operation than the generally accepted commercial technique involving underwater application. When the cables were finally connected, the onshore cable task was successfully completed. The accomplishment of Project AFAR showed that with innovative engineering techniques, significant improvements in the efficiency of even the most difficult surf zone cable installation can be achieved. With projects like AFAR and Tektite 1, the Naval Facilities Engineering Command and the Navy Seabees have demonstrated a growing capability for reliable, safe, and economic ocean construction. The programs already completed and those which will be coming up in the future are part of what is being recognized as man's evolutionary return to the sea. The Navy's successes in ocean engineering and construction have contributed toward conquering one of man's last two frontiers.